Very good. So we have a very intimate audience, and this is session 6C. If you're in the wrong session room, stay, because because Diego wants an audience. He loves an audience. He plays up to it. Our first speaker today is Diego Lopez from Red Iris. He's also the chair of Torino's task force on European. No.
Yeah, I am.
European middleware coordination and collaboration.
Exactly.
I get the last two C's around the wrong way all the time. And he's talking about composable services, and this is what this session is about. And this is about how to integrate building blocks to make something that's useful on its own, more useful when it's able to be configured and managed in a uniform way. So, Diego?
Well, now, okay. How does this move? It's automatic, or shall I? Okay, this right. Well, it should move just with a wave of hand or something like that. Better not, because if it moves when I wave my hands, then it will be continuously moving. Better than not. Okay, so, well, I frankly expect a little bit more interest on this, but anyway, and in fact I have received a few questions about, well, at last we are going to know what GEMBus is about, but anyway, hopefully people will enter afterwards and things will be known, and the word will spread and things will become a little bit clearer in what comes to what GEMBus is and what we are doing. So, the first important thing about GEMBus is that the first thing that when talking with the organizers of the conference, we were talking about this talk, is about precisely what GEMBus is and what GEMBus is not, which is really important. And something which is important is that during the first year review of the GEANT project, we received a couple of comments about, for example, asking us not to reinvent the wheel, that there was a very well-established corpus on ESBs, and it was not wise to reinvent the ESB. Well, I have good news for the reviewers and for those of you concerned about that, because GEMBus is not reinventing an ESB. GEMBus is basically what is said there is intended to be a middleware layer that is intended to support service integration according to service-oriented architecture principles in a multi-domain environment. In fact, you will see that we are not even mandating to use an ESB framework to be integrated. We are using it because we find that it's much easier to use an ESB framework to do service integration. But we are not mandating to use or be part of GEMBus. We are not mandating to be connected to the service bus. It is for sure inspired in the enterprise service bus paradigm with the goals of free application services from common concerns about security, discovery of other services, message management and routing, etc. And with the idea, with the main purpose of go a step beyond the single central authority that is now commonplace in the current ESB systems. ESBs are oriented to solve enterprise environments, and now what we have is working in solving or trying to solve multi-domain, multi-enterprise environments that as are common in our daily practice whenever we go out of the limits of our NREN, or even inside our NREN when we go and try to make different institutions collaborate. So, and we strongly believe that we are taking a step further into federated infrastructures. This is important when talking about federation. It's important that we say simple federation. Everybody thinks about identity federations. It's not about that. We're talking about federating in general services, in federating in general infrastructure, so they can collaborate, keeping independent management and well, based using metadata on the participant frameworks as the backbone of the whole thing. So in that respect, it is somehow similar to what an identity federation is right now. Early in the project, we established these 3 principles about how GEMBus should look like. The idea is that, first of all, the infrastructure was required to be very flexible, able to accommodate, again, existing service frameworks. So we were not reinventing the wheel, preparing a different framework that would require anyone to disconnect whatever they have from the running framework to come to GEMBus. So and the final idea was, and I'll show you a diagram on that, is a loosely coupled bus of buses. Do not require many requirements on services willing to participate, so almost everybody can plug almost anything in the GEMBus and make it work. And provide, to facilitate this, the idea is to provide basic mediation services that make integration much easier. And something that is important and something that is awakening right now is about the service management frameworks that is happening in several environments, and the idea is precisely to provide a common ground to enable the use of these service management frameworks. No. So that's the idea. GEMBus is intended to be that you see there. So, well, several different service frameworks or service platforms interconnected among them through what we're talking about ESB frameworks, interconnected through a standard or normalized mechanisms that are those core service bindings that allow any service at any that allow any service at any ESB to see the other services in the remote ones, in the remote ESB as they were local, and allowing as well and publishing interfaces, so independent service platforms not being based on an ESB or even in the ESB we are using currently, able to interact as well with at least with the core services provided by GEMBus. All of this is coordinated through a common registry that, as I said, is the backbone of the federated environment, the federated multi-domain bus that contains a rich internal format able to collect and publish data about services according to different service classifications, forming an ontology. And the idea, again, is that the registry and all the metadata is intended to be suitable for different frameworks, whether an ESB or a general platform like Axis, or which is the other one, or Spring, and to different ESB frameworks like Apache Service Mix, Swordfish, or whatever. Well, these minimum requirements are basically, well, the idea was limiting them to a set of basic aspects, which are these 4 you have there, about how messages were going to be wrote, so how messages were going to be addressed. So that guarantees the traceability, how security was going to be established through a definite token format, how services will interact with the rest of services through containers, and how they were going to be announced through the registry via descriptions, and the rest. Anything else is left as an end-to-end issue. So inside GEMBus, the idea is that it could have been, let's say, common buses or specialized buses that could take care, for example, of the grid community or several providers collaborating for some with some goal. And GEMBus is committed to provide a set of basic mediation services that we understand are the ones needed to guarantee the interoperability between the different services. Security, basically authentication and authorization. Accounting, in what relates to creating log entries and accessing the results of these logs. And composition, so different ways of composing services are supported. When it comes to being a foundation of a service framework, we intend to support different of them. And while there is a list of the ones who we think are more prevalent in our environment, those related to what commercial providers through ITUT or the TN forum are publishing, or OGSA in the grid environment. The main idea here is to have a platform open enough to facilitate future collaboration between our infrastructures, the strictly research and academic infrastructures, and the commercial ones. So, for example, in this diagram in which you have something which is, I would say, is an archetypical environment of collaborative, composable services, you have a request that goes to a bandwidth management service. Once you get the bandwidth guaranteed, you go to a IT reservation service that makes the brokerage of certain grid resources, and then you have everything in place to start working. The idea is that we would like to see, and we are working to enable that, for example, the bandwidth on demand service would be provided partly or totally by a commercial provider, or the IT resource reservation service would be dealing with external, and when I mean external to the academic community resources. Well, the elements in GEMBus. Basically, we have distinguishing two parts, essentially, which are the core infrastructure, and anything else are component services. Component services are whatever whoever willing to participate in GEMBus is willing to plug at the bus. And the core infrastructure is intended, as I said, to provide interoperability, to ease the interconnection of the different services, and is composed of either specific software elements, like the registry, that is not a service. It is a meta service somehow because it holds metadata about the rest of the services. In general, in most cases, we are committed to make that profiling supporting service frameworks, analyzing them and trying to make a specific configurations of them so as they behave the way we think they should behave to be part of GEMBus, and specific component services that are offered as a normal service, as a component service, but with a general purpose and provided by GEMBus itself. And well, the only things that are required to the component service, of course, is that they comply with an interface. That it was when I was previously referring as service containers. They can be atomic or composite, built by composing some atomics or other composite services. And the idea is two things that is important is that they can be deployed at any participating service framework, anywhere, any of the buses that are connected to the general GEMBus, and that can be dynamically provisioned. This is the other possibility. You can access something that is remotely offered, or you can instantiate and configure a service that is available for you in a service repository. Basically, this is the GEMBus core. Again, this is the glue putting together all the service frameworks, and is composed of these 5 elements: the registry, the message infrastructure, the security token service, the login service, and the service composition. The service, the registry, as I said before, has a rich semantic format storing data about the available services, and support several existing service description formats. Why? Because we want the service to be able to be used not only by people running only SOAP-based web services and willing to use Whistle, but we want it to be useful as well for people running REST-style web service, and so using Waddle. Or, as I said before, we want to maintain service repositories as well, so you can download and instantiate, and so you need to have OSG descriptions and whatever it comes. Apart from that, specific service description formats for service frameworks, the idea is that the registry holds additional service metadata with semantics. The idea is that to have semantics here, and probably you have read about these semantics, web services, etc. This is related, but we try to go in a very practical way without, even when it's said there that it is possible to have complex queries and reasoning, that's important and is part of our goal, but I insist we are trying to follow a very pragmatic approach here. The idea is that it would be possible to feed the registry with different sources, with descriptions coming from different from different individual registries in the participating frameworks. They will be inside the RDF store. They can be searched and queried and combined by the different participating frameworks as well. So via connections, via publish-subscribes interfaces. And the idea is that as well, we will have the possibility of having several instances of the registry, so to avoid the usual problems of having a single bottleneck, a single point of failure, etc. And we are collaborating with something that is the Universal Service Description Language, that is part of the big European projects in trying to find a way of precisely apply this semantical rich service definition inside the for service integration. Jmag, which is the GEMBus messaging infrastructure, is built, as I said, by, in this case, we have found that everything that is around, every component that is around is suitable for what we do, so we don't need to invent anything here, but to tailor what are standard implementations of the message processor, able to adapt data, interceptors, so the different services are talking with, they use somehow a fire and forget mechanism to interact with the rest of services, and the routing module that is in charge of reaching the appropriate destination. Plus a configuration manager, and of course, a set of conventions that define the names and how an endpoint is built and how a certain service, the endpoint of a certain service is named so it can be accessed by the calling service. The security is supported by standard derived from WS Trust, which is a standard inside web services that mandates how security tokens are generated to be included in messages and how security tokens are going to be validated once you receive, or a certain service receive a message containing the token to establish whether this message should be honored or not. Basically, first thing is that user authentication is outside of the GEMBus scope. We expect to be using infrastructure like EduGain, or the results of the Moonshot Initiative, or grid certificates, or whatever relevant source of user identities. And we have split the STS functionality into atomic services. One is for issuing the valid tokens inside the infrastructure. We call it the TTS, the Ticket Translation Service. It's in charge of authentication. And the AS, which is the authorization server, that is, to your surprise, is in charge of authorization. and that takes care of the token validation. They are designed to use, in both cases, external source for collecting additional attributes, so they can decide whether a certain request is valid or not, or to build a more complex token as in accordance to what the receiving service will require, or to make decisions on whether a token can be issued or can be validated, so they can apply policies through policy decision points. And we have defined the usage of session tokens once an association between two services is established, to reduce the overhead on the authorization process and to reduce the depending on the AS as a single point of failure again. So this will in the future alleviate this overhead and make service interaction a little bit or much more efficient. Logging is something that is very important. There was before in session on federation infrastructure in which at least half of the presentations were about logging processing, diagnostics, statistics, etc. And this is a key facility for accounting. If we want to collaborate to the outer world, we will need some accounting as well. If we want to work with infrastructures that are no longer based in physical support, we probably will need as well accounting on our own. And offshore, diagnosing this kind of complex infrastructure is really important, and it's something that we should need tools for that. Well, the idea is to have a handler which is integrated in the messaging infrastructure that collects which interactions has been taking part at the level of the GMI. And at each participating framework, there's going to be a log processor that is connected to common log repositories in general. There is no need of having, again, one central one, and it is possible, given that our plans is to use ADF, and again, we will have intelligent data routing here to direct different pieces of data to different repositories. And be aware of, for example, concerns about privacy, concerns about the amount of information that makes sense that you have to send to the appropriate place. For service composition, we have considered two different approaches just to have the flexibility. Again, as I said before, there are two ways of using services. One is invoking a remote service, sending a request and getting a response, and the other is getting a service instance from a repository, instancing it at your framework and running it according to your configuration. To support both, the idea is to have both an execution engine that runs orchestrations when we are talking about remote services, deciding in which order each service is called and according to the results, which other service to call and which other operations to perform. And on the other hand is the possibility of, if you are instantiating remote services from the repository, you build your own composition locally using a workflow engine that is a service itself. You instantiate the workflow engine and you fill it with the specification of how the services you're instantiating should interact. We have exercised several integration patterns. A couple of them are going to be presented after I finish, about how to integrate existing service in the GEMBus infrastructure. So Vasiliki and Christoph are going to present about this, so I will pass. But we have been playing with them and showing, demonstrating that the architecture was sound and that existing services were suitable to be integrated here without too much hassle for the service developers and the service providers. This is and on the other side, I have briefly described how services can be integrated in GEMBus, but what happens if somebody wants to use GEMBus? Somebody wants to use GEMBus, there is probably the recommended solution will be, go and integrate into GEMBus. You just connect to a participating framework, to an ESB, and the ESB is taking care of everything. There are some adapting elements that we are working on. So again, as I said, it's fire and forget. You just decide, I want to talk with service providing capability X. You send the message, you get the response. You don't care about security. You don't care about service discovery. You don't care about message routing. You can do that locally in your ESB, or you can use even, and that's the one of the advantages of using GEMBus, you can use it remotely by using the binding components. But we are so good. Well, we are not good. I will not say that good, but we have so goodwill that we want to have everybody using us. That means that even if you don't want to use that, and you are running, you don't trust the ESB, the adapter layer, or you want for sure, seriously, you want to have more fine-grained control over what is happening. The idea is to provide an API that will be part, again, of the ESB, so you will be able to do so even if you're connected to a participating ESB. But more important, I think, is that our plan is to provide API connectors for service platforms. So those services that are running, for example, inside an Axis could take advantage of the security service of the STS, just to give an example. So, what have we done? So far, the project has been running for 2 years. During the first years, we concentrated mostly on identifying use cases and selecting the supporting frameworks for developing GEMBus. Second year has been mostly dedicated to define the architecture, prototype the core, and identify integration patterns. And we have that. Vasily and Christoph are going to present precisely about integration patterns and how we have dealt with existing services. I'd say the most relevant services inside the GEANT environment. And apart from that, we have been producing these prototypes. We have a prototype of the registry that currently is being used by another project, which is RS3G, about student mobility. And mind you, and this is important, that we are talking about, Vasily is going to present bandwidth on demand. Christoph is going to talk about network monitoring. And there is some guys out there that are using it for moving student records among universities, which is moving from the very low level at the low layer of networking, talking about fibers and wavelengths and all the like, to moving to the very high level of database records and schemas and the which is the name for that? This is application. Well, from the almost layer 1, from the old OSI stack to layer 7. So bear in mind that we are managing, at least addressing all that. Probably we are not being too wide. Why? And, the STS, we have an STS, a demo for the STS as well, that is running and is being evaluated, for example, by I've been talking with people in the grid community and people in several other projects like Clarin, and they are having a look at it and they're playing with the STS capabilities. We have a composition service that is running. Well, it's running only the part of orchestration because we are waiting for the developers of the workflow service to finish their OG integration. Well, some of them are now available in a demo portal, but not all. They will be soon available. I hope to come here with everything running, but we had some nasty problem with CSS, which is quite curious because it's nothing to do with the real thing, but we wanted to look it properly. So I hope everything will be in place anytime soon. There is a demonstrator of all the concepts about the composition of services, about the distribution among different ESB instances. that implements an application that provides autonomous computing. It's a self-healing system, or self-healing system. And well, there is a demo. Let me, because I took note. If you are curious about seeing that, there is a demo tomorrow during lunchtime between 1 and 2, and on Thursday between 10 and 11 during the coffee break, there in the GEANT booth that is to your left when you leave on that door. So if you're interested, come and see it, because it's, well, I hope it is worth your time. Well, what we have ahead is, I know. What we have ahead is precisely consolidating GEMBus. Our commitment is to dedicate this coming year to make the real GEMBus promise happen. So, while making the core elements stable, beyond the prototype state in which they are now, working something which is important, which is service characterization, identify how a service can be deployed inside GEMBus and the other way around, how whatever service can use GEMBus without becoming part of the GEMBus itself, what is required to be part of the GEMBus registry, and what do we require for a service to become composable, really composable, and be part of the connected through the composition engine. We plan to work precisely on service deployment mechanism, repositories when we are talking about a service that is going to be locally instantiated, containers when we're talking about a service that is going to be remotely accessed, and mechanism for validating, deploying, and provisioning. And of course, and I would say one of the key parts in what we have ahead in the coming year, I know that all this stuff can be really somehow complicated, so the idea is to collect our experience and to write hopefully clear and good GEMBus cookbook that would help us in attract many others to our side. And just to finish, I would like to remark one thing. I was talking about service integration. I was talking about going from the network up to the application. I was talking about virtual services, etc. And I have not mentioned one word, which is part of which has been, I have not said cloud. If you realize I have not said cloud just one time, even one time, once. Why? Because I wanted you to concentrate in something that is nothing to do with clouds. It's nothing to do with the last hype that is sounding around. It's about middleware. I wanted you to chant the middleware mantra. The middleware mantra is this. It's as simple as this. You have a network, you have applications, and you simply put the middleware in the middle to make them work. And that's what we are trying to, or what we are trying to do with GEMBus. And I wanted you to remember that what it is all about. So I'm finished. Thank you very much.
Thank you, Diego. Are there any questions? Hey, more people have turned up. I wasn't watching.
No, not that much, not many, but anyway.
Yeah. No questions?
They're flattened.
Yeah. Diego was...
By the middleware mantra.
Yes.
Chanting inside.
Diego is readily available in all of the breaks and easily identifiable.
And go to the demo. I will be around. If not me, Pedro, that knows much more than me about the integration of the services and everything, will be around. So please go there.
Very good.
Thank you.
Okay. So next up in the Composable Services stream, we have Vasiliki.
Yep.
Yep. That's confirmation that an Australian is able to pronounce someone's name correctly. And yeah, well, I'll let you
Can you
get
hear
started.
me? All right. Yeah, thanks. Hi, everyone. I'm Vasiliki Pouli from GRNet. I'm here to present to you about integrating inter-domain reservation systems with other composable services into GEMBus. Next. Okay. An outline of my presentation. I'm going to tell you about a bit GEMBus. What are the composable services and reservation systems? How we can integrate them into the GEMBus middleware, as Diego said, and some conclusion. GEMBus, as Diego said before, it's developed in the framework of the GEANT project. It's built on top of an enterprise service bus platform, which is a software architecture construct that provides fundamental services to build complex architectures. It's based on event-driven and standard-based messaging engine, the bus. And in this way, we can integrate heterogeneous systems and services and create flexible architectures, infrastructures, and provide the middleware in order to connect applications and networks and build composable services. Some examples of composable services that are already integrated in GEMBus are reservation systems. For example, we use the Autobahn system, and along with that, we use the monitoring system, the perfSONAR, that Christoph is going to present afterwards. Integrating these services into GEMBus, we have the opportunity for the user to log into GEMBus and make a path reservation request. Then the GEMBus can communicate with the Autobahn service, and which is the reservation service, and make the path reservation with the corresponding path reservation parameters that the user requested along his request. And then the GEMBus can also communicate with the perfSONAR system and forward the reservation parameters in order for the perfSONAR to monitor the path. How we integrate this reservation system into GEMBus? As I said before, we use the Autobahn service, which is the automated bandwidth allocation across heterogeneous networks. The Autobahn is an inter-domain network reservation system. It's capable of setting up on-demand dedicated circuits across various domains, irrespective of the underlying technology, if it's Lambda, if it's MPLS, if it's Ethernet, whatever. And for our integration, we used a single adapter that enables the communication for the system and makes the Autobahn a composable service able to communicate with other composable services available to the GEMBus. The single adapter is used before we have a single Autobahn interface exposed to the user, and has the methods that the user can call and make the path reservation. Some methods of the interface are path request, path cancellation, path modification. And here we have the integration schema in more detail. In the light blue box, it's the GEMBus middleware that is built on top of an ESB, the enterprise service bus, in the middle. We have the GEMBus registry, in which every composable service is registered so that anyone can see and call the service that he wants. So for the adapters, we have the reservation service adapter that is used to deploy the reservation service inside the GEMBus. And this adapter acquires all the reservation parameters from the enterprise service bus and is responsible for communicating with the service, the multi-domain reservation service, the Autobahn in our use case, and forward the specific user request. For the user, we have a client interface where he's able to log into this interface. And we have also created the reservation client adapter that handles the user request, takes all the reservation parameters, source IP, destination IP, network guarantees, for example, delay, jitter, and other things. The adapter is able to transform the parameters into parameters that are able to be read by the GEMBus, and also forwards this request into the system. So in this way, through the adapters, a reservation service like the Autobahn service can become a composable service into the GEMBus system, middleware, and can be orchestrated and composed with other services, like a monitoring service, as Christoph will talk about it in a moment. And we can forward this reservation request of the user to the monitoring service in order to monitor the network paths. Some details of the contact details of the team. I'm Vasiliki Pouli. There's also some other people, Kostas Marinos, Mary Grammaticou, and Vasilis Maglaris, that are in the team. And that's it. I was quick before you were a bit.
Do you have questions?
I'm surprised.
No? Stunned silence from the crowd? Exactly. Well, then we'll move on, and we'll. You have anything more to add?
No.
No. Then we'll move on. We'll hear Christoph, and we'll get to break early before all of the birds of a feather sessions. Presumably, I'm supposed to do something and talk to you about all of the birds of a feather sessions that are available this afternoon. But I'll look it up during Christoph's presentation and update you then. So. Integration of perfSONAR into GEMBus. Thank you, Christoph.
Okay, hello, nice to see you. I'm Krzysztof Dąbek from PSNC, the Polish NREN. I want to present presentation about integration perfSONAR with the GEMBus as a realization of the enterprise service bus. Only 2 words about the enterprise service bus and later about the perfSONAR. Enterprise service bus is a software architecture that provides an abstract message exchange layer to allow application communicate to each other. In enterprise service bus architecture, we have 2 kinds of services: the customer services and the producer services, as you can see on the presentation. The perfSONAR is an infrastructure for network performance monitoring that is a set of services. As you can see, the measurement point, measurement archive, lookup service, and a set of services like command line, MP, round robin database, and structured query language. If I can back on the previous slide, because I want to tell only that the enterprise service bus is realizing the service object architecture because of the routing and transforming the messages. In the process of architecting the implementation integration the perfSONAR with the GEMBus, there were proposed two general kinds of integration patterns. As you can see on the left, there is a per service adapter. For each service, we've got an adapter and a binding element that are a group of easy to provide protocols for the developers. I want to notice only that we can have multiple binding elements to the one adapter. For the perfSONAR, there were chosen the per service integration pattern because of the modular architecture of the perfSONAR. Here we can some overview of the perfSONAR integration pattern overview. There are three advantages of using the perfSONAR adapter, per service adapters integration. The first is easy management of the services. We can easy deployment, restarting service. We can restrict access to the one of the service or each service. We can provide statistics of each service, and we can logging the usage of the service. The second advantage is providing for clients, as I said sometime before about the binding elements. We can easily create the endpoints in the Spring Framework configuration file. There are already many kind of easy to use endpoints, such as realization of the SOAP or REST. All we must do is to configure the file to start using the SOAP or REST. The third advantage of using a perfSONAR adapter integration pattern is that we can use already available not only GEANT, but any other services that we can easily deploy on the GEMBus. Or we can start using already existing code for new adapters. Here we can have three types of per service adapter integration. The first is for current provided services. That means we must have an adapter that I will named as interceptor that converts the messages from the bus to the current running services. As you can see, there are also some adapters on the below the GEMBus block that can have multiple binding elements. The second type is based on the current services source code, so we can grab the source code and integrate it into the adapter and provide the service on the GEMBus. The first is the development the new adapter for the new services from the scratch. To the perfSONAR, we used the first from the left, so for the current provided services, because it was very easy for us to integrate the perfSONAR with the GEMBus. The most important is that we shouldn't have a deep knowledge about the perfSONAR source code. We only developed the adapter that was a client for the perfSONAR, and then we connect it to the GEMBus. On this slide, you can see the comparison of the concept on the left integration pattern, and on the right is a current running prototype. You can see in the app GEANT services such as measurement point, measurement archive, and lookup service. Below is a NMWG adapter that is exchanging the NMWG XML schemas between the GEANT services and our enterprise service bus. Below the enterprise service bus block, you can see the three kinds of adapter that we have already implemented. There's a command line MP adapter, RRDME adapter, and SQL ME adapter that has already binding elements in SOAP and not REST yet, but in the future, and client which is connecting to the through the GEMBus with the GEANT services. So I want only to add one notice that this is the first phase of the implementation. The second, we must start to using the GEMBus core services elements, such as service registry, logging, and or security. So this is our future. Okay, thank you. Have you got any comments?
This is not speed dating. Do we have any questions? We do have.
Freek Dijkstra, Sarah. I have a question. I presume that each perfSONAR service will register with the GEMBus registry.
Yes.
If so, will the perfSONAR lookup service become obsolete? And if not, what's the difference between the two?
Between what?
The perfSONAR lookup service. I presume that current perfSONAR services register with the perfSONAR lookup service. If they also register with the GEMBus registry, will you obsolete the perfSONAR lookup service, or will you keep both of them? And if so, what's the difference?
I think a lookup service is a service registry, and the GEMBus registry is only is a registry for the services that are currently running and deployed on them. Maybe Diego will.
Well,
because you have the microphone, so I.
Yeah, no, but have you finished?
Yes, yes.
No, the point is that the idea is that the registry is not intended to be disruptive. I mean, any application that is relying on the current lookup service is free to do so. The idea is that the registry will be available, announcing the in this case the perfSONAR services to any other service that is willing to use perfSONAR. If in the future the people that are responsible for perfSONAR decide to move into to forget about the lookup service and incorporate it into the registry, perfect. We will be happy to do so. But the idea, again, I insist, the service, if I don't know if you can get back to my presentation, because at the beginning, could be possible.
I don't know. Can we
So the idea is to avoid the disruption of the service.
Reverse?
No, but reverse to mine.
No. No.
What?
We can't.
Anyway, so the point is that if you look, there is in some point, yes, good. So slides, I'd say 3, I guess, or 4. 4, yes. So the idea is that, well, so the idea, if you look there precisely, this is this connection between the GEMBus registry and the lookup service. The idea is to aggregate, not to mandate to be disruptive in any sense. Because our idea is that perfSONAR, as it is now, is a running infrastructure. People is using it, is happy with it, have deployed things, have deployed applications. Our idea is to go a step further and to bring make perfSONAR available for other potential applications that are not willing, for whatever the reason, to learn how to integrate perfSONAR inside the code. That's basically the idea. So, well, the same happens with Automa or whatever else that is going to be.
I have a question, but mostly, okay, if the year can answer it, but I want to present a question about actually related to your diagram. You target for 3 services based from perfSONAR.
Yes.
But actually, perfSONAR is more or less centralized service, and you need to consume it by other service. And probably in different domain, multi-domain.
Mm-hmm.
How you solve these issues and which features you use, at least at ESB.
Mm-hmm.
GEMBus is multi-domain, but how you combine, and ESB is a centralized, actually. Mm-hmm. How you do multi-domain services integration?
Oh, the multi-domain problem is a future in the GEMBus. So I think if we can have multi-domain ESBs, GEMBuses, mm-hmm. we can easily provide the multi-domain perfSONAR through the ESBs. I think mm-hmm. it's the only.
Okay, actually,
the message will mm-hmm. will exchange between the ESBs, so we can easy integrate multiple perfSONAR instances through to the GEMBus.
Okay, I would agree. Yes, we need actually. I don't know if there are quite ready solution for, but making inter-domain communication between ESB as a message exchange bus is a solution.
I think, yes.
You go to the demo and you'll see it working. It's what Pedro has done. What they have several different instances communicating among them. Through this kind of this call service findings. So they do that interconnection on both sides. So it's working. It has not been experimented right now with the perfSONAR experiments we made, but it's in the other case it has been. So go there, grab Pedro, and tell him to show you how it is.
The demo is scheduled for tomorrow lunch and Thursday. No, it's in the GEANT booth.
It's in the GEANT booth.
So it's not a listed demo in the demo room. So yeah, the GEANT booth tomorrow lunchtime and Thursday morning coffee break. Any further questions?
This is actually not a question, but I look at the audience and see that not all are involved in GEMBus or close relation has. I would propose to convince people in GEMBus still to discuss the topic how we make security in GEMBus. If I've not missed this in your presentation, because I was a bit late. How much easy or not? Is it simply topic for discussion for this session? Sorry? How it is done? How is security is added or integrated or provided in GEMBus integration? This is what people ask, and we need to convince them.
If I could connect to the internet, I could try to. Well, basically, is there the STS? Can you go to slide more? Go. There. Do you mean this? Yes.
So if you explain this, so...
Yeah, but well, basically the idea is there is a consumer, a service consumer here that is going to connect somehow, and this is out, I insist, this is out of the GEMBus infrastructure on purpose. We don't want to compete with Shibboleth, we don't want to compete with certificates in grids, we don't want to compete with Moonshot, with whatever. Somehow the consumer gets a token, well, that gets a claim identifying the user in which it is going to speak on behalf. So the consumer sends, that is willing to connect to the provider, sends a request for a token to the STS using the credentials that it has collected from the user, using the identity infrastructure. Let's say it's EduGain. It collects some information from EduGain, send it to the STS, and the STS, which is connected to the registry, aware of the security policies that are applied, that can, for example, use this claim to collect additional data about the user, about the service, builds a security token, sends it back to the consumer. The consumer prepares the request for the provider, including that security token. So it's a general message, including a general token, simply that. There is no requirement of the message. The token can be whatever the provider has specified through the registry that it requires. So we could, in principle, allocate SAML assertions, certificates, PGP, you name it, Kerberos tickets. They are sent, and the provider, when receives it, again, sends this back to the STS to say, well, I have received this. Shall I accept it according to the policies you have here for me? And then, if everything goes well, again, the authorization server makes whatever analysis it has to make, collect additional attributes, checks for validates of certificates, do whatever, and sends the response back. Along with this response, to alleviate the problem of having going in this loop every time there is a request of a service, the STS, according to the policy, can send a session token. So this provider can associate a session with this consumer, so further requests will contain only the session token that will last for, say, whatever a session is supposed to last. 1 hour, 1 day, 1 week, 1 year, 1 century. That depends on the policy defined here at the STS. That allows the consumer to invoke subsequent, to make subsequent calls to the provider without going through the whole loop again. That's how it works. It's intended to be, and if you have a full integration in the ESB, this happens here and here. So the idea is that when the consumer issues the message, doesn't care about security, when the provider receives the message, it can trust in that the message is coming from an authorized party and can be replied accordingly. That's the idea. That's how it's going to work. What we have now is here, and the demo is not very impressive because it's a piece of SAML. You hit a button, you get a response, but it's running right now we are running it now in a demo site.
Pardon? Oh, yeah, to keep going. Any further comments? No? Well, I'd like you to put your hands together and thank the speaker. Oh, no. Yes.
For those of you involved in GRID, that is, I don't know if there are many of you here, we were presenting this architecture based on STS to the UGrid PMA because they have plans to support this profile as well as part of the grid security procedures. So hopefully this will become normal grid operations anytime soon. And well, we hope to be there to support them.
Thank you, Diego. Just in other administrative stuff, we've got a little bit of time for the coffee break. Thank you, Christoph. Oh, yeah, he interrupted the clapping. Thank you to the presenters. So we actually have a 3D high-definition robot demonstration happening in the Tyco room. That's the demo room at the back of the PSNC booth. So it's along, I think, that wall, if my orientation is correct. And that happens during the coffee break, so in 20 minutes or so. So you can get a real coffee, and then it's not on? You don't think so? You do think so? Oh, it's the end. Oh, it's the end. Okay. It is. Well, and if you don't want to go home because you like TNC so much, there's actually 5 different events running tonight between 6 and 8 or 6 and 9. So look at your program. You can go to ADVA's optical networking, which is followed by a cocktail reception. There's that's in room B, which is somewhere. You can orientate yourself. The e-culture communities in research networking environments in Virgo, which I think is over that way. End-to-end surface architecture verification in Leo. A telepresence demonstration by Huawei in room A, the plenary room, and the NREN's perspective on web conferencing in Kepler, room D. So enjoy. Well, I'll see you tomorrow if I don't see you at one of these other events later tonight. Thank you.